All right. Hello, welcome. Lovely greetings to all dear viewers who are waiting for another episode in physics. I'm Naveen Karki and I'll be presenting you the ideas and discussion in the topic that's been very categorically and very clearly specified, the current electricity. And this is the first class of current electricity. All right. Now, few things before I start. The first and foremost thing you got to understand, I hope with all the notification you must be clear, but still let me inform. ये जो class है, this is dedicated for students who are class 12th passed and who are, aspiring for upcoming NEET examination. हालांकि because now even the class 12th guys, their syllabus has also been completed, I believe, long back. So even for the class 12th studying as well as class 12th passed, this discussion is going to be very, very fruitful, I believe. All right. Second thing, because this class is been parallelly broadcasted via different channels like the television and the YouTube and other channels. So, the medium of communication will be keeping majority in English. So, ऐसा कुछ रहेगा that will go with 80% or 85% English and 10 से या 15 से 20% हम medium of communication को हिंदी में रखेंगे, right? So, these are the small few things which are very much important. Before you start, I should give you the background of today's class, the basic know-how. So, let's start. Let us begin. So, the next 1.5 hours, we are really going to have some lovely time, some lovely discussion. And for those viewers who are completely new today, all right, there's a number that is via WhatsApp, and you can send your queries, if any. Apart from that, any given question that has been asked, if you want to respond, please do it. So, let me just write the number for you. So, where should I write? Okay. So, that is 9311883484. So, that is the WhatsApp number. Now, please maintain one thing, that while you write your queries, वो जो queries हैं बिल्कुल current electricity का जो current topic है उसी से related होना चाहिए. That's very much important. And apart from that, while you write the query, please do write your name and your city's name as well. वो दोनों चीज बहुत ज़रूरी है. That has to be there. All right. So I think all the discussion, everything is there. Now the flight is ready to take off. All the safety precautions and everything has been discussed. शुरू करते. Now अभी तक all the charges, they were at rest. Yes. Now that was electrostatics. अब हम क्या करेंगे, वो जो charge जो rest में है उससे हम संतुष्ट नहीं है. We are not satisfied by that. तो हम चाहते हैं कि वो charge को move कराया जाए. So we like, or we would want the charge to move, and that factor comes out to be the current electricity. और आज की जो बात है, that is about the it's not about the circuit, it's not about all those things. It is simply about the microscopic behavior, the microscopic properties of current. जैसे कि शुरुआत में, all those idea of drift velocity, mobility, current density, electric field, and so on. And do remember, lots and lots of questions are formed from this segment as well. एक general misconception है among the student. The moment they think, आप एक बार जब visualize करते हैं current electricity, so you think of all the circuit, resistance combination, RC circuit, cells, EMF, and so on. But they miss a very, very vital thing. Current electricity se, at the beginning, the initial phase of the topic, ये है microscopic properties of current. और खास तौर से, I don't know the reason why, circuit part में फिर भी, you come up with a nice momentum, But when it comes with the microscopic properties, I have found, this is my observation, and I wish it to be wrong. Majority of the student, they don't pay that sufficient attention to this topic. और होता क्या है देखिए एग्जामिनेशन में, it doesn't matter कि आपने कितने difficult questions solve करके examination hall गए हैं. What really matters is, if there is a question in front of you, are you able to solve it? Are you able to secure the marks? That is the most important thing that is required. All right. So in the lump sum, what I would like to say is, ये जो initial topic है, they are very very important. And दूसरी चीज, they're quite interesting. Some fragment of students say that, okay, that's a very theoretical part, quite a boring one. But no, there are so wonderful theories and elements and numericals. So you will really get fun in that. So let's start. आज का जो मुद्दा है, that is the microscopic behavior. All right. So we would like to talk about the microscopic properties. All right. So microscopic properties. That's what we're going to do. Let's start. अब अगर current electricity, if you are starting, the first thing that we require is इस current को कैसे measure किया जाए. That is very much important. So let's talk about the average current and instantaneous current. और हाँ, एक बात, because we are focusing for the NEET preparation in this segment, तो हम अपना जो दायरा है वो NEET syllabus और NEET type of question में ही सीमित रखेंगे. इससे कोई फायदा नहीं है कि we do very heavy, numericals. We should be very much target oriented, very much target focused. All right. So what's the meaning of average and instantaneous current? Let's try to understand. बहुत छोटी-छोटी चीजें हैं, but they are very much important. All right. So I'll just take a simple example. मान लेते, you have a conductor. So this is a conductor. All right. And the first and foremost thing, look, there's a major difference from electrostatics. Electrostatics में time and again इस बात को हम बहुत focus कर रहे थे कि inside the conductor, within the conductor, the electric field is zero. The electric field is missing. अब होता क्या है, इस statement को हम इतने बार पढ़ते हैं, इतने बार कहते हैं, but then we forget a fundamental thing. Electric field inside the conductor is zero, but there is a condition applied. और वो condition है only under electrostatic condition. तो अगर आगे से, now you've reached to current electricity, किसी ने ये statement दिया है that electric field inside a conductor is always zero, तो आप इसे false कहेंगे. The electric field inside the conductor is zero only under electrostatic condition. Now, let's try to understand this thing, all right? So, to understand it, it's quite simple. देखिए अगर conductor है and inside the conductor, if charges are moving, तो charges को move करने के लिए कोई ना कोई वजह चाहिए. Certain reason is required for the charge to move. So, what could be the possible reason for the motion of charge? जैसे normal conductor के case में, we connect a battery, और battery connect करते हम कहते हैं, okay, now the current has been established. But ये ध्यान देना, by applying a battery, we establish an electric field, okay? This is an electric field. And due to this electric field, the charges would be moving. Now see, मैं इस बात पे नहीं जाना चाहता हूँ कि a conductor, positive charges don't move, it's only the electron. Those are pre-primary level talks. Now we are preparing for NEET examination, तो हमारी बात में कुछ gravity होनी चाहिए. So I hope you understand that. Actually the electron moves, but conventionally पहले से ही हमारे पूर्वजों ने the motion of positive charge से current को describe करना शुरू किया था. So what our ancestors have been doing, we are simply continuing that. All right. Simple सी बात है. Now the logic is, if there is a current, the charges are moving, and if the charge is moving, there must be the electric field. आप देखिए, बहुत शानदार concept. We started with a very wonderful thing, that electric field inside a conductor is not always zero. That is great. अब बात करते हैं that how can we measure the current. Now, measuring the current में, there is a very interesting thing that you need to understand. Students generally इसको mathematical format में लेके चलते हैं. That's perfectly fine. At the end, आपको mathematics चाहिए. But you should not forget the physics behind it. You should understand. जब भी आपको current measure करना है, you need to go in a cross section. Let me repeat it again. Whenever you want to measure the current, you go and watch the cross section. जब तक आप किसी cross section में नहीं जाएंगे, you would not be able to measure the current. Now the big question is, कौन सा cross section लिया जाए? Is there any specific cross section? The answer is बिल्कुल नहीं. आपकी मर्जी है, आपकी इच्छा है, आप कौन सा क्रॉस सेक्शन में जाना चाहें, perfectly allowed. But remember the story. If you want to measure the current, you got to go in a cross section. All right. तो आप cross section में पहुंचे. Now, what you need to do is that बस गिनती करनी है. You got to count. गिनती किस चीज की? The charges which are passing. तो आपने यहाँ पर एक cross section बना दिया है. Now, right from this cross section, whatever are the charges they are passing from here, आप बस इन charges को गिनेंगे. You would technically count. It is something like, imagine there is a highway and some policemen have got a certain information. तो वो highway में एक barricade बनाते and they start, say a policeman is here, all right? And the policeman starts counting how many vehicles, how many cars are passing through that given cross section or through that given barricade, all right? So, आपको यही चीज करनी है. You got to finalize yourself in a cross section, और इस cross section के through how much charge will pass in a given time, that will be called as current. और सबसे पहली बात, we will talk about the average current. Now let's try to understand what's the meaning of average current. जब भी आपको, not only in current, कहीं पर भी physics में, if you want to decide, if you want to measure average, then you have a certain time span. हो सकता है from 2 seconds to 12 seconds, maybe from 5 seconds to 9 seconds. So there is an interval of time. There is a duration of time. और उस time duration के दौरान how many charges have passed through the cross section, बस यही गिनती करनी है. That's all. So the average current का मतलब, you would see the total charge passing per unit time. That's the case. Now that time interval would be given by the question, that you got to calculate the average current between this time to this time, so that duration would be given. So सबसे पहली बात, whenever you got to measure the current, you got to understand average current. अगर आपको measure करना है, you got to fix a duration, you got to fix an interval. I hope that's very clear, right? Now एक और है, there is what you call as the instantaneous current. Now in a way, instantaneous is also an average, बस वो जो time duration है, that has been shortened, that has been reduced, और जो time span है, उसे इतना कम कर देते, that duration is technically equal to an instant of time. आप language से देखें, for the average current, the question or the statement would be average current between 0 to 5 seconds. Average current between 3 to 5 seconds. जबकि instantaneous के case में, you say instantaneous current at 3 seconds. Instantaneous current at 7 seconds. तो एक specific instant of time ये मेंशन किया जाता है when it comes to instantaneous current. और अगर फॉर्मूला की बात करें, that will be the derivative of charge with respect to time. Knowingly, I will not go कि ये जो expression का origin क्या है, will not go into the derivation because we've got lots of grounds to cover, so we'll be focused up to this point. तो सबसे पहली बात, you know what did we find? कभी भी current measure करना है, you got to finalize, focus yourself in a cross section. और उस cross section में, if you have a duration of time, the charge passing during that duration, that will be called as the average current. Or instantaneous current, that is defined at 1 instant. अब एक बहुत interesting चीज, probably one question might have, occurred in your mind. Now, you may be thinking in this way, चलिए, जब तक हमने uniform conductor लिया है, that was fine. But now, let me take a non-uniform conductor. Imagine that a conductor is of non-uniform shape, all right? Now, the first question is, can we measure the current for this non-uniform cross-section? And the answer is absolutely yes. क्यों नहीं? क्योंकि current measure करने के लिए ऐसा तो नहीं है कि real life में someone would say, okay, because someone has to measure the current, so सारे conductor को uniform लिया जाए. In a real life situation, all the shapes of conductor you'll get. तो question ये आता है कि एक non-uniform conductor के case में cross section कहाँ लिया जाए? Whether at the narrowest part or at the widest part or anywhere. And interestingly, you can take the cross section anywhere, anywhere. अब आप देखते जाना कि किस तरह से concepts evolve होके आएंगे. That means you can take a cross section here, you can take a cross section here. Let us say this is A, this is B. Now, if somebody measures the current through the cross section A and somebody measures the current through the cross section B, guarantee इस बात की है, the value of current will be same. कहने का मतलब, let's take an example, 4-second duration. In a 4-second duration, whatever is the amount of charge that passes through this cross section, उस 4 second के दौरान exactly the same amount of charge will pass through B. So इससे हमें एक बहुत बड़ी आजादी मिल गई है. We've got a big freedom, unimaginable freedom, that you want to measure the current, you go through any cross section. That doesn't matter. And the fact of the matter is, ultimately, the value of current will be same. अब इसी से एक और शानदार concept will emerge. आप देखते जाइए. Now, if I say one thing, all right, that अगर the number of charge that crosses through this cross section in a given time is equal to the number of charge that crosses through this cross section in the same time. ध्यान देने वाली बात ये है, you got to focus, the time duration should be same. ऐसा नहीं है कि यहाँ आप 4 सेकंड के लिए देख रहे हैं और here you would go with 10 seconds. That is not allowed. That is foul. Time duration same रखें. So if you keep the duration of the time to be same, in that given case, you would see the current will be same. All right. Now, there's a point here. NEET syllabus first heading electric current. Yes, Nilesh Drishti, I request you, please put only relevant message. Please don't clog the inbox. Inbox ko jam na kare. And hi, good morning. Great to see you. All right. Now, let's go to the next thing. This is the, I was talking about, ये जो cross section यहाँ है and there's another cross section. I was saying, in that given time interval, the charge entering is exactly equal to charge exiting. इसका मतलब, there's a big consequence. और जानते हैं वो consequence ये है कि if there is a current flowing through a conductor, the conductor is never charged. This is quite interesting. The conductor is never ever charged. Now how come? Let's try to see. अगर आप ये volume of conductor की बात करें, suppose this is your volume of conductor of interest, आप ये पाएंगे in the given time interval, जितना charge is entering, the same amount of charge is exiting. इसका मतलब during a current flow via a wire, the wire is never charged. जितना charge यहाँ से आ रहे हैं, the same amount of charge in that given duration will pass through this. Now see what a lovely concept we found. Completely, a wonderful concept. The conductor is never charged. इसी को, if I would just like to show it in the form of a small question, like say this is a conducting wire, all right? And in this conducting wire, I have connected a battery. So of course, there's a steady flow of current. Now, मैं इसमें एक चीज add up कर लेता हूं. Let us say that this is a Gaussian surface, all right? And there's a current. Now, if I would say, what is the net flux through this Gaussian surface? Now, you may hit the WhatsApp chat box. The net flux is positive, negative, or zero. These are the three options that you have to see, all right? Negative, positive, or zero. A current is established, that is flowing, और हमने यहाँ पर एक Gaussian surface बनाया है, and we want to see, all right, there is one answer, and that is zero, and that's absolutely true. That is absolutely true. Reason, whenever a charge is flowing in a conductor, the conductor is never charged. क्योंकि जितना charge यहाँ enter हो रहा है, the same amount of charge will go there. और conducting wire पहले neutral था, अब भी neutral है. The flow of current does not charge up the conductor. So the flux is going to be zero. All right? So quite a nice amount of property that we have already developed. We've now understood the average current, instantaneous current. Now, ये question, all right, I'll not be doing कि आपको charge as a function of time दिया जाए and you got to differentiate that and you'll find the current. So let's not talk about that. इसका उल्टा, let's see that. If someone gives current, so how am I going to calculate the charge? So let's try to understand. Basically ये है, जैसे I, if I say I as a function of time, इसका मतलब this is an instantaneous current. It doesn't matter whether the current is constant or variable. I have an instantaneous current. और instantaneous current हमें देता है at what rate is the charge flowing. और ये जो current है, that is the current at instant dt. अब इसे अगर मैं multiply कर दूं with the duration dt, remember I was dq by dt, यानी this will give me, ये entire factor will give me the charge that is flowing through the cross section, but in that duration dt. और अगर मुझसे पूछा जाए, I got to calculate the total charge, so with a suitable limit, I can find the total charge that will be circulated through the cross section, all right? So you got to understand both the forward as well as the reverse gear. In the forward gear, with the help of charge, you should be able to calculate the current, and in the reverse gear, with the help of current, you should be able to calculate the charge. और एक और चीज देखिए, नीट एग्जामिनेशन ऐसा एग्जाम है जहां पर एग्जामिनर अलग अलग फॉर्म ऑफ क्वेश्चन देके आपको डराने की कोशिश करता है. दैट्स ऑल. बहुत ज्यादा टफ नहीं होता है क्वेश्चन. इट्स जस्ट अ माइंडसेट प्रॉब्लम. इसी चीज को देखिए, वी कैन ऑल्सो सी ग्राफिकली. अगर हम ग्राफिकली देखें, हम सबको पता है द graphical significance of integration is area. Integral y dx, इसका मतलब है area enclosed by the yx graph. By the same logic, by the same token, integral I dt, इसका मतलब है area enclosed by the current time graph. So quickly, if I have to show it to you, अगर मान लेते हैं this is the current time graph and you have this sort of graph, बस आपने ये area निकालना है and this particular area gives you the charge circulated within this duration of time. Okay, so I hope with this discussion, if someone gives you current, you can calculate charge both algebraically as well as graphically. Let's go with the question, and here's a question for you. The current through a wire depends on time as I equals to 10 plus 40. Find the charge crossed in 10 seconds. You got to do that. Please find it. Please find it. All right, so in order to calculate this, we have both the option. हम graphically भी जा सकते हैं because you could see the current time graph, that's going to be a straight line. Yeah, we can also go numerically, we can also go algebraically. So let me go with the algebraic part, all right? So here is the case. The charge circulated, that will be integral I dt, at least that was the formula that we understood. Let me put the value, that is 10 plus of 40 integral dt, the limit will go from 0 to 10 seconds. That's how it comes. Bas, ab kya karna? We got to integrate it, and I hope so simple level of integration is never a problem for you. Ye aa jayega 10t, this comes out to be 2t square. That's from 0 to 10. That's how it goes. And let's see the value. Upper limit, that's going to be 100 plus. All right, so this is 100 into 2, so that's 200. So I get the charge that is circulated as 300 coulomb. Quite a huge value, 300 coulomb. Actually, बहुत बड़ी value होती है, unimaginably high. But fortunately, NEET examination में हमें उस level का appreciation नहीं करना है. You get the answer, you celebrate it, all right? So I got an answer 300 coulomb from one student. But जैसे कि मैंने कहा था, the name is very much important. So please ensure you put that. Anyway, that's a great thing. अब ये current has a little bit of tragedy. इसके साथ एक दिक्कत है. Tragedy ये है that despite having magnitude and direction, the current is a scalar quantity. All right? It has magnitude, it has direction. Good, Roshan. Okay, it has magnitude, it has direction. Still, it's a scalar quantity. क्योंकि vector होने के लिए having magnitude and direction is the necessary condition, but that is not the sufficient condition. वो एक condition है, लेकिन बस वही एकमात्र condition नहीं है. Apart from having magnitude and direction, the current or any quantity should also obey the laws of vector addition. तब जाके you can say that all right, this guy is a vector quantity. यानी vector होने के लिए it should have magnitude as well as direction and it should obey the vector law of addition. अब current की दिक्कत ये है, it has magnitude and direction, but it does not obey the vector law of addition. Now, let me show it to you quickly that why does not this current obey vector law of addition. If I have, say, 3 wires and this is 2 ampere, this is 1 ampere. So we say, there's a junction, there are 2 currents, 2 ampere and 1 ampere. Therefore, you say कि ये जो current है that is 3 ampere. और इसी को हम Kirchhoff's first law कहते हैं या conservation of charge, किसी भी नाम से कहिए, but that's the answer. A notable thing here is, while getting the value of current as 3 ampere, we did not see what is the angle between the vectors. We did not see. जबकि आप सोचिए, अगर दो forces को add करना है, then unless we have the idea of the angle, we can't find the resultant. यानी current simply algebraically add up हो रहा है. Therefore, despite having magnitude and direction, current is a scalar quantity. फिर भी क्या है, बात ऐसी है कि हम एक ऐसी क्वांटिटी चाहते हैं, we want such a quantity जो वेक्टर हो और उस वेक्टर क्वांटिटी पे जो वेक्टर की डायरेक्शन है, that should be the direction of current. और ऐसा करने से होता क्या है, the direction of the current is been, represented, is been acknowledged in one way. तो इसलिए we talk about the next term, and that next term is called as the current density. Now, I'll talk about the current density. Now, what does that mean? Let me say. सबसे पहली बात देखिए. Current density is a vector quantity. All right? The first thing is that the current density, that will be represented by J, and it's a vector. All right? And you would like to know the direction of J. So the direction of J is same as the direction of current. तो इससे क्या हुआ, वो जो करंट के डायरेक्शन जो हम वेक्टर फॉर्म में नहीं दिखा पाए थे इन टर्म्स ऑफ करंट, क्योंकि करंट के पास डायरेक्शन है लेकिन डायरेक्शन होते हुए भी वो स्केलर था, उस डायरेक्शन को यूज वी डू इट इन द टर्मिनोलॉजी ऑफ करंट डेंसिटी. सो करंट डेंसिटी has the direction as that of current. But then we would like to measure कि current density को कैसे measure किया जाए. Basically, the current density, the magnitude, is defined as I divided by A. Now, this A is a very, very specific area. Now, it means that A is the area which is perpendicular. But the question is, perpendicular to what? Of course, this is perpendicular to the flow. All right? That is how we define current density. कोई भी conductor देखिए, any given thing, you got to think of an area which is perpendicular to the direction of current flow. I'll show it with the help of example. All right? The first thing is that let us take a cylindrical conductor of this particular shape. So this is a cylindrical conductor, and in this cylindrical conductor, let us say that the stream of current has been represented by this. Okay? So this is one stream, this is another stream. Bilkul, the streamlines of the current. And if I want to measure the current density, I got to take the area, but that area has to be perpendicular to the flow. So, ऐसा लेने से काम नहीं चलेगा. हालांकि देखिए, if you have that mathematical maturity, तो अगर आप ऐसे भी लेंगे with little bit of modification, आप चीज कर लेते. It's something like if you know how to ride a bicycle very properly, तो आप कुछ stunt दिखा सकते हैं, because you know that you have that balance. कि अगर आप गिरने भी वाले हैं, you know how to save yourself. So, with maturity, with more and more mathematical understanding, people generally ऐसा area लेने के बाद भी they come to the correct answer. But let's not go into that. इस condition में you got to take this cross section. So if I say this cross section as A, the value of current density will be I divided by A. लेकिन ये ध्यान दीजिए, whenever आप जो area लेंगे, perpendicular तो लेंगे, but दूसरी अहम बात, a second very important thing, that area should intersect the entire stream. ऐसा नहीं है कि आप बस perpendicular लेंगे, right? और आपने बस इतना ही area लिया. Now that will be wrong. Area should be perpendicular, and that area should include all the given stream of current, so something like this, all right? So this much of area is what you will be taking in order to measure the current. Meanwhile, I have a comment here. Let's see, Priyanshu Jain. Does current density show vector law of addition? Perfectly, yes, Priyanshu Jain. That's a good, Priyanshu Jain, yes. So that's a good question. In fact, ये vector है, so it obeys the vector law of addition. और प्रियांशु इसी बात को मैं दूसरे तरीके से भी I'll be explaining it to you a moment later, all right? But that's a valid question, good one. Now, in the similar way, all right, एक बहुत interesting चीज, let's see. Let me take something like this. Let me take something like this. This is a sphere, all right? So this is not a circle, this is a sphere. Now, in that given case, मान लेते किसी भी तरह से, we don't know how, but a current has been established and this is how the current flows. I think this is visible, right? Yes. तो ये जो current है, they are radially going outward. कोई एक potential difference establish किया गया है. A battery has been connected between the center and the outer surface. So let's not go into that headache. वो एग्जामिनर की सिरदर्दी है, इस तरह का करंट पैटर्न कैसे मेंटेन किया जाए. Now if I would say कि अब मुझे करंट डेंसिटी मेजर करना है, then how am I going to choose the area? तो एरिया चूज करने के लिए this is what you go. अब देखिए, what was the golden rule? The golden rule was that जो भी एरिया आप लेंगे, but that area has to be perpendicular to the stream. So therefore, किसी भी wrong tool, okay, all right. So किसी भी given point में, it's not bit symmetric, but let me see, okay. अब देखिए, this is what you see, right? Now let us say this is a sphere at that particular distance, which is r, the white one, that's the sphere, and the value of current density is going to be I divided by 4 pi r square. So which rule did it help? जब भी current density measure करना है, you got to keep two things in mind. Number one, the area should be perpendicular to the stream. Number two, that area should enclose all the given stream. All right? That's very much important. And after that, see, but let me tell you, with maturity, people, start doing all those stunts, and that's perfectly allowed. The same bicycling example मैंने आपको दिया था. Initially, you learn very carefully, but after some time, you start doing all those, drifts and everything. But if we go by the basic, that's perfectly fine. All right, so now there is a question, definition between current density. ये question मुझे थोड़ा ठीक से समझ नहीं आया. एक बार reframe करें, please. All right, now let's see. After getting the value of current density, we now will see इसको reverse करते हैं. And Priyanshu Jain, your question would be perfectly valid here. मान लेते, all right, कि I know the current density, and let's say this is given that cross section. Now you would say this, we can resolve the area. Perfect, Roshan, that's perfect. अब हम क्या करेंगे? See, let me just go with another point. It's something like this. Suppose these are the stream, all right? And the direction of stream hai, that itself is the current density, and that's G. But suppose the question says कि मुझे current चाहिए through this cross section. Someone, ये जो dotted दिखा रखा, that's oblique, all right? तो ऐसी situation में, if you want to find the current, then the value of current comes out to be J dot A. So that's what it comes. So यहाँ से आप देखें, it's a vector quantity, and what is A vector? Magnitude is this, perpendicular आपको पता है, area vector, that is how we calculate the current. और जिसको Roshan साहब कह रहे हैं, resolving the area, that's equivalently good. So guys, now what we have done is that we have understood about the current density and all those things. Now we'll go to the next part, that's the drift velocity. So we'll be talking about the drift velocity and mobility. सबसे पहली बात, let's write the symbol. This is quite big. The drift velocity is represented by Vd. The mobility is represented by mu. Now let's try to understand what's the idea of drift velocity. Okay, Roshan. Fine. I was a bit confused, so that's great. All right, now let's go with drift velocity, and so I'll call you Miss Roshan next time, all right? Okay, Srinjan from Kolkata. Okay, now let's go to the next point now. Coming to the point right here, let's see. First of all, dekho, in case of a conductor, now let us say this is a nice conductor here, I'm making it, and there is no battery, there is no electric field, all right? So what we'll do is that, let's try to understand this thing. मान लेते, right, the charges are here, और आपको पता है, when it comes, okay, okay. All right, now let's come to this point, see. By the way, I just wanted to find Roshan from Lucknow. We can resolve that area. So, okay, Miss Roshan, that's great. I think I'm correct now. Okay, now let's see. Coming to this case, this is a conductor or conductor. There's no battery. There are the charges. They are the electrons. Or room temperature mein, because of thermal agitation, the charges would be moving randomly, all right? So it comes something like this, yahan aega, it will collide with a lattice, kisi ek lattice se takrayega electron, and then the direction will change randomly, and again after that it goes in this way. There's another interesting thing. Is there, this is all, there's no battery. This is all because of the word, you must be knowing that. That's what we call as the thermal agitation due to temperature, all right? So temperature ke karan se, jo charges hai, which is the electron, they are moving, and you know what? The charges are moving with tremendously high speed. Speed ki value bahut zyada hai, somewhat in kilometer per second. Speed की value वहाँ तक पहुँचती है. But point ये है, that speed is not unidirectional. That speed is not, in a patterned way. That is very, very random. इस कारण से अगर कोई भी cross section area हम उठाएं, let's say you typically take any cross section area, तो आपको कुछ ऐसी स्थिति मिलेगी, like say one electron passes through this cross section in this way. You know, there are electrons moving very randomly, very large in number. तो कोई ना कोई electron आपको मिलेगा जो इस तरफ opposite direction में pass कर रहा होता. So कुल मिलाके, the complete idea is the net current would be 0. So there are certain term, yes, so that's correctly said. It's a Brownian motion bhi kaha jata hai. Yeah, let's keep it simple. Let's do it as the random motion. Now, what's happening? The electrons are there. They are free. They are free to move. They move with tremendously high speed. But us speed ko hum, because we don't have a unidirectional speed, we don't get the current. Kyunki koi bhi cross section denge, as many electrons are crossing right, you would find the same number moving left. So the current is 0. It's something like an untamed elephant. There's a huge motion, but the outcome is nothing there. लेकिन हम क्या करते हैं? We would like to encash this opportunity. तो हम करेंगे क्या? If I apply an electric field, बहुत ध्यान से देखना, एक interesting way. Look at the difference in wording. Normal case में हम कहते हैं, all right, a battery is connected. यहाँ पर ध्यान से देखना. I found this is one point where students don't understand it in that detailing. ये जो electric field has been produced, that's due to the battery. All right? तो रेगुलर सर्किट के केस में maybe a circuit mechanic would say, okay, I've connected a battery. But because we're talking about microscopic properties of current, so microscopic properties of current के केस में वही जो बैटरी अप्लाइड है उसे हम दूसरी भाषा में कहते हैं an electric field is set up. So remember, ऐसा नहीं है कि just to set up an electric field you would come with that big Van de Graaff generator. It's not that. आपने बैटरी कनेक्ट कर लिया, so next time remember this rule of thumb. Microscopic भाषा में हम कहते हैं an electric field is set up. But who sets up that electric field? Of course, the battery. All right? And now let's just try to see. Let us try to see an electron which was originally, moving in this direction in absence of the electric field. In absence of the electric field, now will get a force in this direction because negative charge, the force will be opposite to that of the electric field. As a result, consequently, होता क्या है? The electron's motion will be deviated. अब इस बात की उम्मीद बिल्कुल ना करें कि ये इलेक्ट्रॉन बिल्कुल ईमानदारी से इस तरफ जाने लगेंगे. No, that does not happen. You need to remember already this velocity is tremendously high. Tremendously high. It goes in the range of kilometer per second. But because of this electric field, we get one tiny achievement. That achievement is very, very tiny, and it's something like this. It is something like this. The path of the electron would be modified in this way, a curve, preferably that will be a parabola, because the electric field, if it's constant, that would be a parabolic path. होगा क्या? We get a little bit of drift in this direction. और ये जो drift है, that's very, 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 very less. जैसे कि random velocity के कारण से kilometers per second की speed थी, drift के कारण से it comes in millimeter per second. तो इनके बीच में कोई भी comparison नहीं है. कहाँ राजा भोज, कहाँ गंगू तेली. Exactly the same fact happens. The random velocity is very high. The drift velocity is very less. लेकिन drift velocity के केस में we have an advantage, and that is it is unidirectional. Because जैसा एक इलेक्ट्रॉन यहाँ से it suffered a drift in this direction, हर इलेक्ट्रॉन within this conductor will suffer that drift. कम हुआ तो क्या हुआ, लेकिन उसमें एकता है. There is an unity, all right? There is a unity, and that is what creates the current. So RMS velocity is there, it's very high, no problem. We salute you, you're very high. लेकिन आप हमारे किसी काम के नहीं हैं. That drift velocity is very less, but we love you because you are the one which is generating a uniform motion in one direction. तो आगे से जब भी करंट के केस में चार्ज की वेलोसिटी अंडरस्टैंड करनी है, we would not take the RMS velocity, we will take the drift velocity because that is where we are interested in. अब एक काम करते हैं, right? How much will be the drift velocity? The drift velocity will be directly proportional to the electric field. I would again like to tell you, ये जो electric field का मतलब, it's just the effect of the battery. Microscopic भाषा में वो जो potential difference को हम electric field के terms में कहते हैं, alright? So you could see, and that's quite logical. अगर electric field की value, if it's very high, the drift will also be higher. But that's directly proportional. But शायद drift velocity एक और चीज पे depend करेगी. And you know what? That is the spacing of the lattices, right? Because आप देखिए, दो अलग-अलग material. Say for instance, one is steel, other is aluminum. आपको पता है दोनों के lattice spacing, if it's different, तो जो टकराव एक के केस में बहुत जल्दी आ सकता है और अगले के केस में थोड़ी देर बाद आएगी, right? So, apart from depending upon the electric field, it would also depend upon the lattice structure. इसका मतलब it also depends upon the nature of material. So in that given case, the proportionality constant would be broken by, or the proportionality sign would be broken by a constant, and that constant is called as the mobility. And clearly this is expected that mobility would depend only and only on the nature of material, right? Now let's try to understand this. Because in case of conductor, the direction of electric field will be opposite to that of the drift velocity, क्योंकि charge जो है that is negative. तो अगर आप इसको बहुत formally complete definition देना चाहते, you got to do this. Vd vector is minus of mu times E, indicating that the electric field and drift velocity will be opposite. Jahan mu, we've already said, that's the mobility. And if I just want to put the value of mobility, that mobility is equals to E tau divided by m. Now, this is also very, very important. Now, just to catch your attention, because I know medical candidates, they really love this sort of representation. Okay, so this is all dedicated for you. In the boxes, that means something very important, all right? Aap dekhiye, mobility, that's E tau by m, where E is the charge of electron, m is the mass of electron, and tau, that is the relaxation time. Tau is the relaxation time, or relaxation time का मतलब है average time between two collisions. दो collisions के बीच का जो average time निकाला जाता है, because things are so random. Maybe one collision will happen in a short duration, the other collision will happen relatively in a longer duration. तो इनके जो average value है, that is called as the relaxation time. साफ सी बात है, दो अलग अलग material के लिए E and m will be same because they are universal constant. But tau, the relaxation time, depends upon the spacing. Spacing of what? Spacing of the lattices. So clearly it means its dependence is on the nature of material, right? Okay, now after that, let's go with another, और ये जितने भी points what I am explaining, I am assuming कि आप बहुत ध्यान से लिख रहे हैं, because in सारे statement में every statement has a potential question hidden in it. दूसरी बात करते हैं, let's go with this expression. बहुत ध्यान से देखिए अब. A very lovely expression, that's what we're going to do. And that lovely expression is something like this. ध्यान से देखिएगा. मान लेते the battery is there. देखने का नजरिया है, कहने का तरीका है. If you say battery, microscopic people would say, we are microscopic people, so we'll not take battery, we'll say there is an electric field. But at the end, you know, that's same. एक काम करते हैं, let's measure the current. उसके लिए we'd be requiring certain parameters. सबसे पहली बात, n. Now, small n is the number density. Number density of what? Of course, of electron. Now, as I've been saying, I would expect हर एक statement को आप बहुत seriously you are writing it. Physics है, modification कहीं से भी आ सकती है. डरा नहीं रहा हूँ. I'm just, telling it. In fact, ये तो खामखा physics और physics वाले बदनाम हैं. Otherwise, the topic is marvelously interesting, all right? So remove that mindset. It's difficult. It's very lovely. It's investigative, all right? Okay, number density of electron. So it depends upon the nature of material. Like copper will have certain number of electron density, and of course I'm talking about free electron density. Bounded electron anyway is none of our interest, since they are not contributing in the electron, all right? दूसरी बात, ये ध्यान दीजिएगा, because very beautiful questions are formed. Imagine if you have copper, all right? So the shape has been made very random. The number density at this zone and the number density at this zone that will be same. It's something like a density, right? So number density does not depend upon the shape. You must have seen those questions जहाँ पर cross section change कराया जाता है and people would say which parameter is higher, which is lesser, such sort of question you get. So basically you got to understand the number density depends only and only on the nature of material. It has nothing to do with the shape. अब एक काम करते हैं. Let us say, let me introduce some more parameter. I have VD, that's the drift velocity of course, and cross section area, that is A, right? Now let's try to understand this thing. Guys, what we'll do is something like this. In order to measure the current, हम ऐसा करेंगे, we'll see that I'll take a cross section area, or is cross section के through how much charge will pass in that given duration. आप देखिए first definition, the same thing we are there. इसीलिए you know we got to, भले आप definition memorize ना करें, but you got to understand the essence of derivation. अगर मुझे current measure करना है, I got to go with a cross section. अब आप ऐसे भी कह सकते हैं कि क्रॉस सेक्शन कोई भी लिया जा सकता है, तो आप कहेंगे मैं ये लेना चाहता हूं. Agreed, you're technically right, but unnecessarily आप adventurous बन रहे, unnecessary आप length of numerical निकाल रहे, अब बढ़ा रहे. अगर आपको adventure से इतना ही ज्यादा प्रेम है, तो आप बंजी जंपिंग जाए. That's a good way of treating your adventure spirit. But physics है, कम से कम समय में how to solve it, so let's not be unnecessarily adventurous, all right? So this is that cross section area, and I want to measure the instantaneous current, or instantaneous current. The definition of that is dq by dt. Now what does dq represent? That charge which passes the cross section in the duration dt. dt duration के दौरान जो charge इस cross section को pass कर रहा है, that charge is dq. So what I'll do is that मान लेते, all right, this much charge would be passing through this yellow cross section in times dt. बस मुझे dq की value निकालनी है. First of all, let me see कि इस space के अंदर how many electrons are enclosed. So n is the number density, cross section area multiplied by Vd dt. Now this gives me the number. बहुत ध्यान से देखिए, number density multiplied by volume, that's going to give me the number. और कौन सा volume? That volume which is shaded. और यही volume क्यों? Because we are targeting to find the charge which are crossing the cross section within an interval dt. So every move has a certain logic behind it, okay? So you got to understand that logic. But so far we've got only the number. But हमें तो चाहिए charge. कोई बात नहीं, number मिल गया है, बस इसी number के साथ if I multiply by E, that's going to give me the total charge enclosed in this shade, and per unit time, that's dt. So this comes out to be NEVD multiplied by A. Now this is how you can see the current, and that value of current is this. It's a very, very important expression, NEVD multiplied by A. मुझे नहीं लगता है कि इस चीज को मेमोराइज करने के लिए आपको कोई भी सस्ता नेमोनिक बनाने की जरूरत है. वैसे भी मैं बहुत ज्यादा नेमोनिक्स पे विश्वास नहीं रखता हूं, क्योंकि आप इतने ज्यादा ट्रिकी फॉर्मूले गाने वगैरह याद रखेंगे कि उन सारे गाने को याद करने के लिए एक और गाने की जरूरत है. सो इफ यू हैव रियली अंडरस्टूड समथिंग, इट विल फ्लो आउट नेचुरली. NEVD multiplied by A, all right? Okay, now that was a nice discussion. The next thing we are going to talk about is the Ohm's law in microscopic form. सब चीज हम define कर रहे हैं, but we are trying to define it in a microscopic form. Now let's see, let's go with a quick computation. Let me start with V is equals to I multiplied by R. So I've started from this point. Now V will be written as electric field multiplied by L, jahan, what is L? L is the length of that conductor, right? So that's the length of the conductor, or yahan par brother battery is connected, and this is the direction of the electric field, so that is V. That's how we get. N, current, that is I. R is rho L divided by A. यहाँ पर आते आते फिजिक्स में वेरिएबल की बहुत ज़्यादा किल्लत पड़ती है. You know, we fall badly in short of variables. वही rho, which was used for volume charge density in electrostatics, by the time you come here, that becomes the resistivity. तो ये context to context में वो symbol को हम पहचानते हैं. Alright? So rho is the resistivity, not resistance. दोनों में अंतर है. R is the resistance, and this is resistance, while rho is the resistivity. And resistivity depends upon the nature of material. जैसे कि पुराने example में हमने एक shape बिगड़ा हुआ copper लिया था, and we said it doesn't matter, the shape is different. The number density there, the number density here, that's same. उसी logic से the resistivity, that also depends only and only on nature of material, right? And I would make a little bit of change here. That comes out I by A is equals to E divided by rho. That's what you get. And we say that, hey, I by A is J. And 1 by resistivity, that is conductivity. Again, we are falling short of variables. Sigma, till electrostatics, that was used as surface charge density. But now, the same sigma is used for conductivity. And that's the reciprocal of resistivity. And it also depends only and only on nature of material. And that comes J equals to sigma E. And guys, that was what we were searching for. J equals to sigma E. This is called as the Ohm's law, right? The Ohm's law in microscopic form. So this is the Ohm's law in microscopic form, या Ohm's law in point form, whatever you would wish to say, point form, ये भी कहा जाता है, right? J equals to sigma E. Now, the counterpart is V equals to IR. देखिए मैं बार बार इस बात पे जोर दे रहा था that potential difference microscopically we see the electric field. ये analogy है. Current microscopically we look at the current density. और जो resistance था microscopically in a point form we talk about conductivity. So J equals to sigma times E. Now this guy is a vector, this guy is a vector, and sigma is always positive. Value कम या ज़्यादा हो सकती है, but we never have negative conductivity. So let's talk about the direction. जिस direction में electric field है, ध्यान से सुनिएगा, right? You can just do it. Electric field जिस direction में है, positive charge flows in the same direction. और जिस direction में the positive charge flows, actually the direction of the current is same. और जिस direction में current है, वही है current density. इसका मतलब, if that really confused you, if that's an electric field, positive charge would move in the same direction. इसका मतलब the current is in the same direction. और जो current की direction है, we know current density इसकी direction भी वही है. So here we come, J vector is sigma into E vector. That is how we establish. That was quite a big achievement. J equals to sigma times E. There is another microscopic property में we'll be talking about resistivity. इसके बारे में और detail चर्चा करते हैं. Let's talk about that, alright? और अब करना क्या है? I just need to compile all the discussions that we had done so far. Like the first thing we talked about, that was I equals to NEVD multiplied by A. The second expression that we had, VD is equals to mu times E. The third expression that we had, J equals to sigma E. Up until now, we had quite a lengthy discussion, but nichod ye hai, saransh ye hai. These are the three terminology, and I believe aapko pata hai what depends on what, right? Jaise ki conductivity, that depends only on nature of material, something like that. अब हम क्या करेंगे, इन तीनों को we will blend it. So let's put it in the mixer grinder and let's see what is the outcome. अब ये तीनों को we are just trying to blend it. So let's cook it, all right? Okay, now ये जो given expression है, that will be J equals to NE multiplied by VD. That's what you get. I by A, that's J, and I know that VD is mu times E. I know that, right? And similarly, mu, that is E tau by M. That's what we got, right? So I get it here. Mu is E tau by M. So E tau divided by M multiplied by electric field. That's what we get. That is what we get. I think that's clear, right? I by A, that's J, NE VD. VD के बदले में we have put it as mu times E. And E के, mu के बदले में E tau by M into electric field. That's what we got. And J now comes out to be N E square tau divided by M multiplied by electric field. Then we suddenly say, hey, can I compare this expression with this? और हम कहेंगे बिल्कुल क्यों नहीं? Let's do that. Let's compare these two expressions. And in doing so, I get the value of conductivity as NE squared tau divided by M. That's the value of conductivity, right? And if I say the reciprocal of that is the resistivity, which is M by NE squared tau. This is another very much important expression, the expression of resistivity. So if you wish, I'll keep this in a big box as well. So the entire outcome of the discussion that we have done so far, that is this one, right? So aap dekhein, we have come up with a very interesting thing. That's about the resistivity. Ab baat karte hain, let's see कि resistivity depends upon what. जैसे कि देखिए एक चीज तो हमें पता है that resistivity depends upon the nature of material और साफ देखिए it has no dependence with the geometry. Geometry के साथ कोई dependence नहीं. It's something like density. Like water, you keep it in a cubical container, you keep it in a spherical container. At the end, the volume may be different, but the density, that will be 1 gram per cc in both. So resistivity purely depends upon the nature of material, and that's what we have seen here. All right, now let's see. Some more interesting thing coming out. Okay, now let's see. Okay, so this is M, the mass of electron. Now, ये तो सभी के लिए same है. The number density for different material, the number density varies. Relaxation time, this also varies with material. Different material has different relaxation time. तो इससे ये बात स्पष्ट तरीके से हम समझ पा रहे हैं कि resistivity केवल nature of material पे depend करती है, right? Not on geometry. But हाँ, अगर material अलग-अलग लें, the value of resistivity changes. Now, one step further. So we say that, we agree that if I change the nature of material, the resistivity changes. But अब हम क्या करेंगे? एक ही material में सीमित रहेंगे. We are going to confine within one material itself. And let's say if I change the temperature, whether the resistivity will increase or decrease, let's try to understand that. All right, now let's see here. Thank you very much for the kind words. Okay, now let's see. Resistivity is m by ne squared tau, all right? अब हम बात कर रहे हैं एक ही material and say I increase the temperature. अगर मैं temperature बढ़ा दूं, this guy is going to say that I will not change. This guy will not change because material एक ही है, so the number density that will remain same. The charge of electron, how can it change? But there is relaxation time. और relaxation time को हमने इस तरह से समझा था, the average time between two successive collision. Now, if I increase the temperature, the agitation would be higher. The electron will start moving with a higher speed. I'm not talking about of the drift speed, which is a random speed. So because I know with increase in temperature, the relaxation time decreases. Wow moment, that's great. So in fact, there are certain words which I use like wow moment. अभी और एक दो words आपको मिलने वाले हैं with the passage of time. That is great. Okay, now let's focus here, all right? So let's go with some more wows. Okay, so m by ne squared tau. With increase in temperature, no, tau will decrease. Speed अगर faster हो, the relaxation time will decrease. इसका मतलब resistivity बढ़ जाती है. So got to remember one thing, that let's write it in a symbolic form, all right? With increase in temperature. With increase in temperature, the relaxation time decreases. The relaxation time decreases, resistivity increases. Yani conductivity decreases. No problem. Conductivity decreases, all right? But do remember, now there's another important point. ये जितने भी चर्चा हमने की है, ये valid है only for conductor, because you got to remember all the story that we began, that was for conductor. That was for conductor, all right? So you got to understand this thing. Conductor के लिए temperature के साथ साथ resistivity बढ़ जाती है. Although semiconductor is not the present context here, but I'll tell you one thing. In case of semiconductor, let me just write it. If I have a semiconductor, with increase in temperature, अगर temperature की value बढ़ जाती है, then conductivity decreases. This is in the case of semiconductor. जबकि conductor के case में देखिए, और NEET इन्हीं चीजों पे आपको फंसाता है, right? Not big thing. They just catch small things and they just see your presence of mind. आपने किस तरह से अलग-अलग चीजों को consolidate किया है, capture किया है. That's what it says. Well, the story of semiconductor is something different. So it's better we not talk about that. फिर भी मैं आपको जरा सा hint दे देता हूं, because if we explain something, right, you have a higher probability of retention. So something, another wow moment, let's see. ध्यान से देखिए. एक कहते हैं ना कि एक अमीर व्यक्ति और एक गरीब व्यक्ति both have the problem of money. It's a fact. A rich person and a poor person both have problem of money. एक गरीब व्यक्ति को पैसों की समस्या ये है कि पैसे कैसे जुटाया जाए, ये समस्या है. लेकिन एक रिच पर्सन के लिए समस्या है, मेरे पास ऑलरेडी पैसे हैं, इस पैसों को मैं कैसे इन्वेस्ट करूं. That is another issue, right? So both have the problem, but the nature of problem is different. और वो कहते हैं ना कि अमीर होके गरीब होके दोनों ही केस में अगर पैसों की प्रॉब्लम है ही है, तो हम अमीर वाले प्रॉब्लम चूज करेंगे. That's the philosophical thing, but let's come to this point. Now the poor person has the problem how to earn money, and the rich person has the problem how to invest my money. Exactly, that's a difference. Semiconductor के केस में already there is a huge shortage of electron, right? So if you heat it up, आप temperature बढ़ा देंगे और ज़्यादा electrons आएंगे conduction band में to participate for that. और ज़्यादा इलेक्ट्रॉन ज़्यादा conductivity. So we say conductivity increases with temperature and the resistivity decreases. But that's for semiconductor. यहाँ क्या था? Temperature बढ़ाओगे, charge carrier की संख्या बढ़ जाएगी, and that's the primary thing we require. Now this conductor is a rich guy. ये कहेगा मुझे electron की तो कोई कमी है ही नहीं. I already have electron. बस ये electrons को channelize कैसे करूं? That is the problem for the conductor. Now if I increase the temperature, randomness of electron will increase. दूसरी भाषा में relaxation time कम हो जाती है. Exactly the same thing I'm trying to give you in a different language, right? So we say if you have a conductor with increase in temperature, randomness increases, so resistivity increases. So the story of conductor and semiconductor is different. ऐसा नहीं कर सकते कि one shirt fits for all. We can't do that. We need to understand the theories and everything. All right, now let's go to the next thing. Okay, now we'll come up with the numerical. Sorry, someone has posted the question. Change in, this is a mechanics one. We'll be focusing only here. All right, now let's see. A steady current. Now look at the word. एक word बहुत मायने रखता है. Steady current. All right, that means steady state has been obtained. Flows in a metallic conductor of non-uniform cross section. So something like this. अब मुझे random ही बनाना है तो मैं जैसा मर्जी बना दूं. So let me make it something like this. So this is a way how you make a random conductor. All right. अब जरा ध्यान से देखें. State which of the quantities, that is current, current density, electric field, drift velocity remains constant. Guys, you'll get another wow moment. हालांकि because अभी तक the concept has been discussed systematically, layer by layer we have increased the concept. So I'm pretty confident we'll do it very easily. जैसे कि देखिए, we'll take two cross section, all right? That's one is at A, other is at B. We'll take this. And now let's just try to understand A or B pe. I think the value of current would be same. Because you remember current measure करने के लिए what had we said? मायने नहीं रखता है कौन सा एरिया ले रहे हैं. बस कोई भी एरिया ले लो, इस एरिया में जितने charges would pass in a given time, इस एरिया में भी the same number of charge would pass per unit time. In other words, we are saying the current would be same. So that means the first thing I get is IA is equals to IB. All right, that's the first thing. So current is done. How about the current density? Current density, that J is I divided by A. Now because I have same current here and here, but the area here is greater, so I get yes, so JA would be lesser, और यहाँ पर क्योंकि बस ये कहा गया है changes or not, so I'm getting right answer. Yes, current constant, density changes. Perfect. अब बात करते हैं electric field. Now before that, let me talk about electric field. ये थोड़ा सा फसाऊ है. You may slip here, you may slip here. ध्यान दीजिए. Electric field के केस में please don't apply V by L if the shape of the conductor is not uniform. A little bit of reason I'll tell you. Go back to the good world of world of electrostatics. Electrostatic में we define E as minus dV by dr. But अगर electric field constant है, minus dV by dr can be written as V by L. The problem with us is that we think electrostatic का concept, okay, we seal it there, we don't use it here. So इस बात को, I don't know how you're going to memorize it. Write it in your wall, write it in your paper, make a tattoo, whatever you do. But ध्यान दीजिए, E equals to V by L. That's valid only and only when the conductor is uniform. Yes, this is a wow moment for me because now you've realized. Before I say it, you've realized. So that is wonderful. अब जरा ध्यान से देखिए, इसका तो chance है ही नहीं. तो निकाले कैसे? ये एक्सप्रेशन J equals to sigma E, the Ohm's law in microscopic form. Because conductivity here and here, that is same. Remember, conductivity depends upon the nature of material. Now the nature of material is same, so that's from, yes, Ohm's law in point form, not the vector form. So J, sigma is same, J is different, that means electric field at A will be lesser than electric field at B. And what about the drift velocity? Let's see. Drift velocity के लिए there is a very interesting thing. और आप देखना, how am I going to link multiple things? If you know the answer, perfectly fine, but just get concentrated into what I'm saying. बहुत ध्यान से सुनिएगा. There's another beautiful thing. आपको physics एक अलग नजरिया से दिखेगी. Let's try to see that. Okay? Let's see. Let's talk about the current. Current is you see NEVDA. हम बात कर रहे हैं drift velocity के, right? So let's talk about the drift velocity. Okay. Let me go with this way. Multiple ways से दिखाना. I'm very excited right now just to show you. And you know what? VD is equals to mu times E. We know that. Now mu is same. The mobility that depends upon the nature of material. By the way, our ancestors in physics have named it very technically. कैसे देखिए? ऐसे word देखिए. Rhyming एक बार देखते हैं. आपने पढ़ा होगा समान लय शब्द. The rhyming words, right? Resistivity, conductivity, right? Mobility, all these ET families, they depend only and only on nature of material. Think about it carefully. Later on after the class, you'll get a nice thing, all right? The mobility here and here is same. So mobility is constant. So electric field यहाँ पर B पे ज़्यादा है. So we say drift velocity at B is greater than drift velocity at A. And that ends the story. That ends the story. All right. But now, let's try to see it through other way. And that is what I have been waiting. That visualization is what I'm trying to give it. Let's simplify physics. Let's see. Let's bring some wow moment. ध्यान से देखिएगा. I equals to NEVDA. Look carefully. I, same, we know. Number density, same, we know. That depends on nature of material. Electronic charge, that's same. Oh my God, I'm getting area multiplied by velocity is constant. ये तो एक जानी पहचानी सी equation है. Back to fluid. That's the equation of continuity. And that has to be there because there liquid was flowing. Here charge is flowing. वहाँ था fluid current. यहाँ पर है electric current. So if you say that I want to use equation of continuity, you are allowed to do that. Perfectly allowed. बस देखिए जहाँ area ज़्यादा है, velocity कम है. So people fail to realize. वो सोचते हैं कि समस्या क्या है. हम कहते हैं current का मतलब something which gives the shock. बस इसी को current हम कहते हैं. And that is where we do the mistake. Current means anything which is flowing unidirectionally in a pattern way. That's current. Now, if heat flows in a pattern way, that's called as thermal current. If liquid flows in a pattern way, then I'll check it out. Don't worry. If liquid flows in a pattern way, that's called as fluid current. And if charge flows in a pattern way, that's called as electric current. Answer same आया देखो. Area into velocity is constant. B पर area is less, तो drift velocity will be greater. Continuity यही कहता है ना. जहाँ area कम है, velocity will be greater. So either you see through this way or you see through this way. It's entirely your choice. So I hope microscopic property of the current. Now you got that microscope with you. मैं ऐसा बिल्कुल नहीं कहूँगा कि आप इतनी चीजों के बलबूते पे no, drift velocity is different. Drift is different क्योंकि A into V is constant. जहाँ area कम, drift velocity ज़्यादा. चाहे आप इससे देखें, देखिए VD इक्वल्स टू म्यू ई, E जहां ज्यादा ड्रिफ्ट वेलोसिटी वहां ज्यादा, या इससे देखें ड्रिफ्ट वेलोसिटी इज डिफरेंट. ऑलराइट, so now my chat window has disappeared from my screen, so I assume that you've understood it. All right, okay, now let's say I was saying it's not that कि I'm giving you a guarantee कि आप ये पढ़ोगे तो आप नीट के क्वेश्चन निकालने लगोगे. You know, this is the trigger. This is the trigger, but you need to participate. You need to do the questions. But एक बात की guarantee जरूर है कि आप वही microscopic view of current, when you start approaching, I guarantee you come up with a confident view. अब आपके पास thinking and reasoning capacity, at least I've done my every effort to inculcate that reasoning ability, and that way, you know, you can take it in a very logical way and you would be eased from the burden of memorizing so many things. So allow me to sign off. I'll certainly catch you up in the upcoming one. Till then, take care. Bye. Cheers.